So, very good evening, my dear students, and welcome back once again. This side Govind your chemistry mentor, and this video you are watching on my YouTube platform Govind Chemistry. As I promised that I will make a separate video for questions for first law of thermodynamics. So that video number 7, question based on first law of thermodynamics. Okay, so that we are going to discuss. So first question and second question we have completed in the past video. So this is the question number 3. What is mentioned here? Read the question once. 1 mole helium. 1 mole helium means helium is monoatomic gas. Yes or no? It will also help. Monoatomic gas heated from 27 to 327 degrees Celsius at constant pressure, and second is constant volume. Find for first and second heat exchange and work done. These are the things which we have to find out. Okay, so one by one we will find. First, constant pressure. We are talking about constant pressure. So at the constant pressure, children, Q is equal to what? N Cp delta T. Okay, so in that case Cp is not given, but you can find out here. I am telling you how to find out. Cv is equal to F by 2 R. So F is equal to monoatomic gas, degree of freedom is 3, and R in calorie approx 2. So it will be 3. Cv is equal to 3 calorie mole Kelvin. Then Cp is equal to, children, Cv plus R. So Cv is what? 3. R is what? 2. So it is 5 calorie per mole Kelvin. So according to the given formula, Q is equal to N, number of mole, it is given 1 mole. So 1 into Cp is 5, and temperature difference 300 means 327 minus 27, so that difference is 300. No need to change because we are calculating change here only. So it will be plus 1500 calorie. So that is the heat exchange. Now delta U is equal to, that formula for always true, NCV delta T. At this place 1 into Cv place 3, delta T again 300. So it will be 900. It is also positive, 900 calorie. By the use of first law of thermodynamics, we can find out delta U is equal to delta Q plus delta W. So delta W is equal to delta W is equal to what? Delta U minus delta Q. Sorry, it will be delta W is equal to delta U minus delta Q. So delta U 900, delta Q 1500. So here the value will be around so what is the answer now? So minus 600 calorie. That is the work done. Got it? Any confusion? Minus 600, that is the W. So we have calculated Q, heat exchange, and work done. Both we have calculated. So minus 600 means, children, minus means what? work done by the system, work done by the system. Okay, in the next case, number 2, constant volume. So at the constant volume, children, what we have to use? Again, q is equal to ncv delta t. So 1 into 3 into delta t is what? 300. So it will be plus 600 calorie. And w is equal to, direct formula you can apply, minus p external delta v, constant volume. So delta v, change in volume, is 0. So w is equal to 0, direct. If you want to apply formula, then check it. Delta u is equal to delta sorry, delta u is equal to what formula? N cv delta t, then same value again, plus 900 will come. Okay, and here it is also 900, not 600. So if you will put the value, in that case delta u is equal to delta q plus delta w. Delta u is what? 900. Delta q is what? 900. 900 cancel, then delta w is equal to 0. Like this also you can calculate, or you can apply direct formula in the case of constant volume. So that is the explanation of this question. Next question, question number 4. In an isobaric process, in an isobaric process means for an ideal gas, find the ratio of delta q upon delta w. That ratio you have to find out. Options are given: gamma, gamma plus 1. Second option, gamma plus 1 upon gamma. Third option, gamma minus upon gamma. And fourth option, gamma 1 minus gamma. These are the options given. Okay, so children, isobaric process means what? Constant pressure. So this is constant pressure. So constant pressure means what? Find out delta q. Delta q is equal to ncp delta t. And what is delta u? Delta u is equal to ncv delta t. So w is equal to what? Delta u minus delta q. Delta w is equal to what? Delta u, from the first law of thermodynamics. So put the value ncv delta t minus delta q ncp delta t. From here, what is common? N and delta t, then cv minus cp. Find out the ratio, children. What they are asking? They are asking delta q upon delta w. Put the value. Delta q is what? N cp delta t upon n delta t cv minus cp. So this n cancel, delta t cancel. What we are getting? Cp upon Cv minus Cp. So divide this by Cv. So what happened? Cp upon Cv, Cv upon Cv, Cp upon Cv. Cp upon Cv is what? Gamma, Poisson's ratio, I told you. So what it will be? Gamma upon 1 minus gamma. Which option? Fourth option will be correct. Next, question number 5. In an isothermal process, in an isothermal process, 150 joule of work done on an ideal gas calculate Q and delta U. Again, same time, very simple. So W is equal to, isothermal means temperature constant. What is the meaning? Temperature constant. 150 joule of work done on a system. On a system, 150 joule work is done. So W will be positive, 150 joule. So delta U is equal to what? Delta Q plus delta W. And you know that, children, if U is equal to, U depends upon internal energy. Sorry, this internal energy depends upon temperature. Temperature dependent. Okay. So here they said temperature constant. So U will be constant. So delta U will be 0. So 0 is equal to delta Q plus 150 joule. Then delta Q is equal to minus 150 joule. That condition only for what? Ideal gas. For ideal gas, delta U is 0. Change in internal energy is 0. In the first, or I think in second lecture, I told you this thing. So now we will solve some question related to the graph. Five, six. Question number 6. This graph is given from A to B. Here, this is 1, this is 2, this is 3, this is 2, and this is 4. Okay. The question is, in this process, AB, A to B, delta U is equal to plus 200 joule. Find delta Q. Okay. So again, simple question, children. What you know? W is equal to, pressure is changing, minus P external delta V. gas is expanded, see, A to B, so expansion, in that expansion case delta V will be positive, yes or no? I told you earlier also. So delta U is equal to what? Delta Q plus delta W. U is given, Q they are asking, W we don't have, so W you can find out. W is equal to what? Area under the curve, so this area you have to find out, it's a trapezium, so W is equal to what? 1 upon 2, parallel side 2 and 4, so 2 plus 4 sum of parallel side into height, so this is your height, so it will be, sorry, this is 3 here, not here, this 3 is here, so it will be 2, so here 6 atm liter, convert it into joule, so how to convert, I told you, what, 6 into 101.3, so it will be minus, because gas expansion then sign will be minus, minus 607.8 joule, so put the value here children, 200 joule is equal to delta Q minus 607.8, this is also joule, so find out delta Q is equal to what? 200 plus 607.8, so it will be 807.8 joule. Okay, so this is the question number 7. Question number 8, this time graph is given, pressure versus volume again, here A to B, and here this is A1 and this is 2, here this is volume V1, increase it, here that volume is V2. In that case they are asking, the question is, options are given, Q1 is greater than Q2, Q2 is greater than Q1, Q1 is equal to Q2, and fourth option is none. Okay, children, tell me one thing, suppose for first process, here this process, W1 is equal to minus Y, and for second process W2 is equal to minus X. So both process, for both process delta U1 is equal to delta U2, because delta U is a state function, not depends upon the path followed by the system, depends upon the final and initial, and final and initial values are same, so it's a path function, state function. In that case what you can use, Q1 plus W1, Q2 plus W2, so Q1 minus Y and Q2 minus X, this equation is coming. Think about it children, here first system it is covering this much of area W, more area it is covering, and here this is covering this much of area only. W2, more area, more work. So here y, 1 for y, this y, and 2 for this x. So which is greater, children? Q1 or Q2? Here you are subtracting a small value in that Q1, and here big value you are subtracting, then also the equation is equal. Then who is big? Q1. Once again I am saying, here from the Q1 a small value you are, a big value you are subtracting, and from this x a small value you are subtracting, even though they are equal. Y is small, yes or no? W1 is what? This area, whole area, this area, this is y, and W2, this is x. So this is more amount, this is less amount. So more amount you are subtracting, even though it is equal to Q2, then Q1 is greater than Q2. That option will be correct. Question number 8. 8 is completed. 9. Here again PV curve. The process is A, B, C. Okay, and for ABC, A, Q is equal to plus 5 joule. So what is W? Options are given: 0, 5 joule, minus 5 joule, none. So it is a cyclic process. How to calculate, children? Cyclic process, delta U 0, state function always 0. So delta U is equal to delta Q and delta W. So 0 is equal to delta Q value plus 5. So delta W is equal to, children, minus 5 joule. C option is correct. So last question for this video, and first law will be finished. So question number 10. Focus on it. It's an important question, and at the same time we will solve around 12 question, 12 question in a single video. Here A to B, B to C, C to D, D to A. Okay, and this system is for ideal gas. So first question they are asking, WAB is equal to what? QAB and delta UAB. So they can ask in different way this question. You have to check it. Okay. So tell me A to B work. A to B work. So a straight line. Many time I told you straight line. Then WAB will be 0. Yes or no? So for A to B, children, A to B, what is constant? Volume is constant. Yes or no? Volume is constant. So in that case, PV is equal to nRT, volume constant, then pressure. If you will increase pressure, then temperature also increases. Pressure is directly proportional to temperature in this case. So if you will increase temperature, then what about U? So U depends upon temperature in ideal gas. U also increases. So if U increases, then internal energy increases, then change in internal energy will be positive, yes or no? If U increases, internal energy increases, then change in internal energy will be positive sign. So it is greater than 0, yes or no? Then formula, delta U is equal to delta Q plus delta W. Delta U is positive, think about it. Delta Q, W is equal to 0 for this process, so delta Q is also positive, so this is also greater than 0. Like that question they will ask. From the same pattern, question number 4, WBC, QBC, delta U, BC. Okay, that they are asking. So B to C, check it. Gas expanded. So B to C is what? It's a rectangle. So what is the work? Get gas expanded. Gas expanded. Yes or no? What I am saying. Let's focus focus on it. Gas expanded, that means B to C, gas expanded. So W is equal to what? Minus P external, and delta V, and delta V is what? Positive. So work will be negative. Negative means less than 0. Less than 0. Then QBC, B to C what constant? B to C pressure constant. B to C pressure constant. Again, PV is equal to nRT. Then temperature depends upon volume. Temperature depends upon volume. So if volume increases, then U also increases, then delta U will be positive. So delta U will be positive. So here delta U will be greater than 0. Okay. Now Q how to calculate? Check it here. Again, delta U plus delta Q plus delta W. Delta U positive. Q is equal to what? We have to find out. Delta W negative. Delta W negative means something X you assume. Okay. So delta Q is equal to what? Positive. Make it Y. Okay. Assume it Y. So it is plus Y delta X delta Q plus X. Sorry, work is negative. Sorry. So it will be X. So delta Q is equal to what? Y plus X. So it is also definitely greater than 0. So here also greater than 0. So like that, C to D and A to D also you can find out. So this is all about the questions practice of first law of thermodynamics. they can ask question from different pattern for the question number 10. In languages also they can ask, so you have to focus, children. So thank you for watching. I hope you enjoyed my video, you are getting knowledge from my video, your benefit is going on. So thank you once again.